this portion right here. As you can see, we have a number of different functions. We have, I believe, f, f prime, f double prime, f triple prime, and then f, fourth derivative. I don't believe I have a fifth one up there. What you would like to do right now is you would like to look at this graph, and I talk with the people next to you, and you want to try to figure out which one is the original function and which one is maybe the first derivative of that original function, okay? See if you can talk with the person next to you. I'm going to let you look at it for about a minute. Make it a little bit larger here, okay? See if you can figure out which one is the original function and then which one is the derivative of the original function. Talk, think about something, go.
I think red. Yes.
That's what I'm thinking. I was gonna say red. How big? Well, I'm gonna go with red. Well, because like this red's the color of my blood, so that doesn't.
And you can't live without your blood.
Exactly. You would die.
And you can't live a derivative prime.
Yeah, it
You
is.
can't live without it.
So it's me surprising how that works.
Is there multiple? It's like.
I think that it's.
Yes.
It's always negative. The derivative always negative.
Yeah,
Can you
definitely.
imagine just going
And then that one's positive.
that way?
So it's not the- this one.
Because I just think
Okay.
So we go this one, this one,
I really don't.
And then I just.
10 seconds.
50-50.
Peroxide, I messed it up.
Yeah.
So we're always-
Oh, look, I made Christmas colors.
3, 2, 1. I heard a lot of very intelligent statements made. You don't even necessarily have to pick out the original function or its first derivative, but can somebody say something intelligent about these graphs at all to determine which one is a derivative of another something? Aiden, you said something.
The lime green one is always, the derivative of it is always negative.
Yeah, if you notice the lime green one as well as the purple, would everybody agree that the derivative is always negative?
Yes.
So that means that the yellow one must be the derivative of either the green or the purple one. Agreed?
Yeah.
And the derivative of the red one and the yellow one is always positive. Therefore, the green or purple would probably be those derivatives, right? Now, something very important to notice here is this piece right here. I want you to look at the blue, and I want you to look at the red, okay? Notice the blue is the only one that crosses the x-axis at 1, isn't it? The red one crosses at a half, isn't it? Is there any function up here that has a derivative equal to 0 at 1? Is there any function up there that has a derivative of 0 at 1? No. Everybody agree? Like, if we see that it crosses over 0, so there would have to be some type of graph. Like, for example, if you saw this, if you saw a function like that, you're like, oh, yeah, the blue one's the derivative of this parabola that's upside down because it's got a slope of 0 right there. But you don't see anything like that, do you? Okay? So that's an indication that the blue one might be the first one. Notice how it's a little bit of a guess and check method, isn't it? Okay? So I'm going to start with the hypothesis that F is equal to the blue. And then I'm going to move to F prime and see if my hypothesis works out. So if I have the blue function as the original, which one would then be the derivative? Don't say it out loud. Take 20 seconds, talk to your peer next to you. Which one would be the derivative of the blue? Talk to your friend. Talk quietly. Five, four, three, two, one. Okay, which one is the derivative of the blue? The red, because the slope of the blue is negative and the red sits below the x-axis. The slope of the blue is, and the red sits above the x-axis. The slope of the blue is 0 and the red is 0. See that? So that, I'm pretty certain at this point, would you guys agree that that it would seem like the first one was the blue one, and then without a doubt, the red one is the derivative of the blue. We know that for sure. I guess it's possible that the blue one could be f prime, and then the red one could be f double prime. But we know the red one is the derivative of the blue one. That seems very, very, very plain to see. So let's go off that hypothesis. Let's try to find the next one. So I've got f double prime. So tell me something about the derivative of the red function. It is always positive. Therefore, the derivative must be above the x-axis. You guys are doing a really good job with that analysis. I can see the things that we've learned through this class. That's going to help you a lot on the AP exam, these type of ideas. Recognizing that its derivative is positive, so therefore must sit above the x-axis. So is it the green one or the purple one?
Green.
It is the green one. Why would you say that?
Because there's a slope of 1/2.
Yeah, you see the closer kind of graph there? If you were to just say, look at the slope of the red graph, what's the slope of the red graph right here? 1, and what is the height of the green graph at that spot? 1. Do you see how those match up? Whereas if you were to say the purple graph, the height of the purple graph is more like, say, 3 or something at that spot. So in fact, the green graph is the next function in line. What is then the derivative of the green function? Why? Because it's always negative, so it sits below the x-axis. We have yellow. And finally, f, fourth derivative. So we only put 3 tick marks up there before we get to this. Obviously, the last one's going to be purple. Okay? And there you have it. So the first part of your assignment will be to look at different functions, and I want you to know that will be a little bit confusing for you. Some of these are a little bit confusing, which is why we have a workday built in this week. You may need to ask some questions, and there's nothing wrong with just guessing and trying to see how it works out. And then if you mess up, then come back and check another, okay? All right, example 2 says find the first and second derivatives of the following functions. The fact is that first derivative is often used. Again, this section is called higher derivative, so we're taking more than one derivative. It is very common to take a second derivative, not very common to take a third derivative. And you're wondering application into real life. Those of you taking physics, any physics people here? Okay, a couple people, physics. So we say that the first function is the position function, and the derivative of the position function we say is the velocity function. And then the derivative of the velocity function, which is the second derivative of the position, we say is the acceleration function. And it also works out that the third derivative of the position, which is the second derivative of velocity, which is the first derivative of acceleration, is equal to what we call the jerk function. And that does not get used very often. You might find that as you take higher level physics courses. I'm not seeing that application. We are going to confine ourselves to this point of study, and that application will be tomorrow. So if you are gone tomorrow, tomorrow's lesson is the most important one to watch. And if the video isn't posted, I believe that your teacher posts all of them from previous years. You could go onto my YouTube site and type in 3.8 and try to find what appears to be the similar notes, and that would take you through that, okay? All right, so let's do the easy problem. First derivative.
4x to the third power minus 8x plus 2.
Does it just feel good to... Remember we used to like limit it at h goes to 0, we plug in x plus h, we go to town with that? Now it's like, thank you, power rule. Right? What's the second derivative? 12x squared is 8. We're done. Can we all agree to get that problem right on the test? Okay. That's it. Okay, different process. How do we find this derivative? Chain rule. Let's use Mr. Gentz's way of trying to make it a little bit easier. What's the derivative of the inside? 2 times the outside would give us 10 times the inside left alone. The second derivative, if you want to make the table, the boxes, you can. But again, the derivative of the inside is 2 times the outside would be 20, and then you drop the 4, you would get 80. So you see now, using the chain rule, we can make quite simple, can't we? Sometimes you don't like to go that quickly, and instead you would like to do something like letter C, where you maybe want to set up the boxes. Oh, yeah, the way that your notes came out compared to what I have, it's all different. This really, like, I will tell you, I can't even begin to tell you what this was like trying to teach through hybrid and through COVID. That was hard. And so things have just been rearranged over the years. So I do want to let you know that as we've divided this up, I apologize I didn't get you notes yesterday, but some of that is not because I'm trying to, again, I'm not trying to make things easier on myself. I'm trying to figure out how to best divide this up for your learning. And I think that this is the happiest I've been about the structure of, I'm actually going to keep it, I plan on keeping it the same for next year. I think that this is the best way for us to go about. We'll see how you do. But I'm going to do the chain rule here. I have u to the 1/2, and I have 2x minus 3. The derivative of u to the 1/2 is 1 over 2 roots of u, and the derivative of 2x minus 3 is 2. So when you multiply those, what's going to happen? Yeah, so you get the derivative, f prime of x is equal to 1 over the root of 2x minus 3. Now, you have two options here to find this derivative. What would your options be? Quotient rule or? Yeah, I would choose to use the chain rule. I love the chain rule. I'm not a big fan of the quotient rule. I love the chain rule though. And so I get 2x minus 3 to the negative 1/2 power. Okay, a lot of times people write 1/2 there as opposed to negative 1/2. So you have u to the negative 1/2, and you have 2x minus 3. We know the derivative of 2x minus 3 is 2. But what is the derivative of u to the negative 1/2? Negative 1/2 u to negative 3/2. So when we multiply those, the 2's will cancel again, won't they? And we're left with f double prime of x is equal to, what are you going to have in the numerator? Yes, I will have a negative 1, and the denominator I'm going to write is 2x minus 3 raised to the 3/2 power. And that's my second derivative. There's going to be multiple applications this year where you need to find both a first derivative and a second derivative. The second derivative is very useful, not just for acceleration, but for other things as well. Okay? All right, so our last two problems, this one is super fun. It is a good time. The one before that is, it's not as fun, but it's kind of crazy to see how it works out. Oh, I keep doing that. Like if I make a box, it'll all of a sudden disappear, but it doesn't work like that, does it?
Then why do you do it again?
Because if I go to the, I'm recording right now, just to make a point and to make you smile, but if I go to the whiteboard, that does have a lasso option. But when I use the whiteboard, then it doesn't record this screen because then I'm off of the Chromebox. So I need to make extra space here just because I can't write very small and still have you guys see it. So we have theta times cosecant of theta. First derivative, piece of cake upside down. What rule do we use? Product rule, good. F prime of theta is equal to, and this is F, and this is G. So I have F prime G plus G prime F, which will be cosecant of theta. Times?
I was going to say times 0.
Yeah, the derivative of cosecant of theta is negative cosecant of theta cotangent of theta, correct? So when you multiply those together, I'm going to get a minus theta cosecant of theta cotangent of theta. And that's my first derivative. We're going to need a second derivative, aren't we? So you've got an option here for finding your second derivative. You either could do the product rule twice, couldn't you? Or instead of doing the product rule twice, you could factor out a cosecant and then use the product rule once. Do you see that? Which option would you like to choose? Okay, do you want to factor out a positive cosecant or a negative cosecant? I would do that as well. So that would be my approach in this problem. Okay, and you might ask, how do you know what to do when you don't? That's part of the strategy of approaching mathematics, is to be able to find those. So we have f prime of theta is equal to, I have cosecant of theta times 1 minus theta cotangent of theta.
Bless you.
So now we have f double prime of theta. Okay, and so we start. What is the derivative of cosecant? Good. Now what? That's f and that's g, right? So times the 1 minus theta cotangent of theta. Now we have plus cosecant of theta times the derivative of that, right? Right here? Oh, you're wanting the derivative of cotangent. The derivative of cotangent is negative cosecant squared. Okay, so we're going to deal with that in just a second. But as we do, we need the derivative of this guy right there. And so I'm going to use just a little bit of space right here for 1 minus theta cotangent of theta. So what is the derivative of 1? 0. So you can see that that's going to go away for us. So now what rule do I have to use there? The product rule. What's the derivative of negative theta? Negative 1 times cotangent of theta. Okay? Plus or minus plus a negative theta times what's the derivative of cotangent of theta? Negative cosecant squared of theta. So you can see that those two negatives will cancel. And so you can see that the derivative of g is the quantity negative cotangent of theta plus theta times cosecant squared of theta. And that's pretty ugly, isn't it? I used to have us kind of go through, we distributed terms when we looked to see if something would simplify. I don't think that really is going to help us. I've become much more familiar. So the AP Calculus exam has released practice problems from all the way back to 1960, and they release them about every 4 years. So that's the first thing I did is I went through and I did every single one of those tests. I don't see this so much as an issue coming up of trying to simplify that. But knowing the structure of the problem, knowing to do the product rule twice, that's an important step. See what I'm saying? Okay. So yeah, everybody can see with the positives and the negatives and the thetas and the C's and the S's like that, it looks kind of jumbled mess, doesn't it? But that is a useful derivative for us. So we'll just leave it like that. Okay. Everybody good? Okay. So this one, our last one of the day, this one's a fun problem. I come back to it every year and it's pretty cool. Okay. It really is. I think you're going to like it. So we end with this for today. We want to find the second derivative of 9x squared plus y squared is equal to 4. First of all, does anybody know what shape that makes? Close. It makes an ellipse. It makes an ellipse. Because if those numbers are not the same, then it makes that shape. Has everybody seen like how you can type that into Desmos and get a picture? Have you guys used Desmos before?
Yeah.
It's really cool to type that in. In fact, the problem that we did yesterday at the end of class, remember how we came up with that tangent line was x is equal to 1, that vertical line? We could type both those in and verify. And I'll do that right after we maybe get through this so you guys can see that that works out. But Desmos is just a super cool feature, especially because you can graph things that are not written as explicit functions of y equals. So how do we find that derivative? It's not solved for y, right?
Yeah,
We learned how to do this yesterday, right? Yeah, we use implicit differentiation, okay?
18x plus 2y.
Yeah, so we have 18x plus 2y prime is equal to 0. Good. So mistakes are people forget to write the y prime or people forget that the derivative of 4 is 0. So good job. Way to go. So we're building off what we did yesterday. I need to solve for my y prime, so I subtract the 18x. 2y, y prime is equal to negative 18x. As I divide by the 2y, I get y prime is equal to negative 18x over 2y. Or in other words, negative 9x over y. Are we okay with that?
Yes.
Okay, cool. So that's the first derivative. Let's move on to the second derivative. The second derivative. How are we going to find the derivative of that? Quotient rule. Derivative of the top, negative 9 times y minus y prime times negative 9x all over y squared. Now, we'll clean this up a little bit, but one thing, first of all, you have minus and it's a negative 9x, so everybody agrees that those are going to turn to plus, correct? And then the other thing is that we have a y prime. We don't want y double prime is equal to something with a y prime in it. So we need to take this, because that's what y prime is, and we're going to drop it right in here. Okay? And so I'm going to try to carefully write that out to be y double prime is equal to a negative 9y, and I'll write that over 1, minus, and I wrote minus because it's a negative 9x. When I plug in for y prime, this negative 9x over y, whoop, I already have the negative. I don't want to do that again. 9x over y times a positive 9x over 1. And that's all over y squared over 1. So when I first talked about substituting that in, Hannah had kind of this angry look on her face because she could see that you were going to come up with this complex fraction. It's not as simple as just plugging in, say, the number 9. That would have been very handy, wouldn't it? Yeah. But instead we get this. So we've got to simplify this. So thoughts on what you want to do first? Yeah, common denominator, so we'll multiply top and bottom here by y over y. And so I get y double prime is equal to, and it looks like a negative 9y squared minus or plus minus 81x squared over 9x times a 9x. Over what? Y is my denominator, good. Over y squared over, good. So I have one fraction at the top, I have one fraction at the bottom. How do I simplify that?
Wait, I have a question.
Yes.
What? Because you had to multiply this one by y too, so isn't it?
No. This one, the denominator was already y because they're being multiplied together. So I can just leave that alone. So in order to simplify this, I multiply by the reciprocal, so times 1 over y squared. And we get y double prime is equal to negative 9y squared minus 81x squared sitting over y cubed. Let me notice something at this point. Yeah, so it's just, maybe it doesn't go anywhere, but maybe it does. Jordan says, hey, she's a little curious right now. She's just saying, well, I see this negative 9 there. What if I factor out a negative 9? What are you left with if you factor out a negative 9 there, Miss Jordan?
Y squared minus plus 2.
Plus
I mean,
9
yeah. I don't know.
x squared, right?
Okay, Joe. Yeah.
All over y cubed. We're calling her Joe now? Okay, I didn't know you were called Joe. So
I actually call her JoJo Siwa.
okay, what?
JoJo Siwa.
JoJo Siwa?
Do you know who that is?
No.
Look at her.
So,
Are you,
She was from Dance Moms.
Matthew told me to not,
Her dog's name is Bobo.
which I'm now
Joe and
concerned
Bobo.
why Matthew knows about JoJo Siwa.
I've sort of seen it and I just don't want
You just blocked it out. Okay, all right. Thank you for your honesty, Matthew. You know what, Matthew? For that, I'm taking you off wall shame. Because you're the one that calls her JoJo Siwa, so you deserve to be up there.
Here, I'll show you JoJo Siwa.
No, I don't want to ruin my day. Okay, I want to see this right here, because JoJo Siwa is a great idea right now. Okay, so JoJo is like, hey, we're gonna factor that out. This is the moment. You've got to see it. I can't do anything to help you.
Four.
Yes.
You're so smart, Alex.
Oh.
What is y squared plus 9x squared equal to?
4.
It's equal to 4.
Oh.
What? That's why I said 4 equals. Oh.
9x squared plus y squared is 4. So that 4 just drops right in there. And so that actually simplifies. Yeah. And we get y double prime is equal to negative 36 over y cubed. Oh, that's so cool.
What?
You already figured that out?
Figure it out.
That's pretty sweet right there.
Yeah, that's what
Yeah.
Wow. All right, look up JoJo Siwa.
I already showed him a picture.
I'm going to stop recording first.
You gotta look up a